The writers of The Last of Us sat down one day and said, "What's the most terrifying thing we could base a show on?" And instead of making something up, they just Googled it. What you're looking at is based on something real, not a monster someone invented, not a creature from a nightmare someone had. This is a thing that exists in actual forests right now, where a fungus has completely consumed an ant from the inside out and is using its corpse as a launch pad. And I need you to understand something before we go any further. The Last of Us toned it down. Welcome to Aberrant Files. Let's back up. The year is, well, it doesn't matter what year it is. This has been happening for millions of years, and it will keep happening long after you and I are both gone. In the tropical forests of Brazil, Thailand, Ghana, and yes, parts of the United States, there lives a carpenter ant, Camponotus leonardi, perfectly ordinary ant, goes to work, carries things, minds its business, and somewhere on the forest floor, while doing absolutely nothing wrong, it makes contact with a single spore. The spore is from a fungus, Ophiocordyceps unilateralis. You can't see it happen, the ant can't feel it happen, but something has just begun inside that ant's body that is, and I want to be precise here, deeply, profoundly wrong. Here's what happens after that spore makes contact. It doesn't enter through a wound, it doesn't need one. The fungus dissolves through the ant's exoskeleton. The outer shell of the ant, which is essentially its skeleton, just gets eaten through. Once inside, the fungal cells begin to multiply. And here is where it gets interesting. Scientists expected to find the fungus in the ant's brain. That's the obvious play, right? You want to control something, you go for the brain. That's what we do. But Ophiocordyceps doesn't touch the brain, not directly. Instead, the fungal cells spread through the ant's entire body, surrounding the muscle fibers, not destroying them, surrounding them, like a network of invaders who have infiltrated every room in a building but haven't made their move yet. They also, and researchers published this in 2017 and I think about it constantly, secrete chemicals, compounds that interact with the ant's central nervous system from the outside. Not by taking over the brain, by talking to it, sending signals, whispering instructions through the ant's own biochemistry. The ant is still technically in control of its own brain. It just starts receiving very bad advice, and then comes the behavior that made scientists' jaws drop when they first documented it. The ant climbs. Now, ants climb things all the time. That's not weird. What's weird is where it climbs to. The ant leaves its colony. It abandons its work, its nest mates, its entire life, and it climbs to a very specific point on the underside of a leaf. Not just any leaf, a leaf at a very specific height above the forest floor. Researchers measured it, typically around 25 centimeters, high enough for optimal humidity, high enough for spore dispersal, low enough to not be disturbed by wind. The fungus has calculated this. It knows the forest better than the ant does. And then, at solar noon, when the sun is at its highest, the ant bites down on the leaf vein with its mandibles and dies. Well, dies. What actually happens is the fungus seizes the jaw muscles directly and locks them shut. The ant can no longer release its grip even if it wanted to. The ant is now a fixture, a mount, a platform, and the fungus begins the next phase. Over the next 1 to 2 weeks, the fungus consumes the ant's body from the inside, and then it grows out. A stalk, called a stroma, pushes through the back of the ant's head and grows upward. It can extend several centimeters above the body. At the tip of the stalk, a capsule packed with spores. The capsule bursts, and those spores rain down onto the forest floor below, landing on other ants, starting the cycle again. The Last of Us asked, what if this happened to humans? The real scientists asked something slightly different. They asked, how does the fungus know to do all of this? Because here's what makes Ophiocordyceps genuinely keep you up at night remarkable. There are over 200 species of this fungus, and each one has co-evolved with a single specific host. Ophiocordyceps unilateralis targets carpenter ants. There's another species for bullet ants, another for weaver ants, another for beetles, another for spiders. Each one has developed a completely custom toolkit of chemicals, behaviors, and timing, tuned over millions of years for one specific victim. This fungus did not accidentally learn how to do this. It evolved an instruction manual, species by species, body by body. So, The Last of Us. The show posits that a mutated cordyceps fungus makes the jump to humans, creating the infected, creatures driven by the fungus to spread, bite, and transmit. Here's what they got right. The real fungus absolutely does spread through spores. That part tracks. The real fungus absolutely does override host behavior. That tracks too. The ant absolutely does become aggressive and disoriented before death. Here's what they changed. The real Ophiocordyceps cannot infect mammals. Full stop. Mammalian body temperature, around 37 degrees Celsius, is lethal to most fungi. Our immune systems are also substantially more complex than an ant's. And the real fungus doesn't want you to bite anyone. It wants you to climb a leaf and die quietly so it can rain spores on your friends. Honestly, the real version is more disturbing. The show's fungus is chaotic. It just wants to spread, destroy, infect. The real fungus is patient. It has a plan, it executes the plan, it doesn't deviate from the plan. It has been running the same plan for millions of years, and it has never once failed to find a new host. The show gave the fungus a temper. The real thing has precision. And now the part of this story that I think is the most disturbing thing I have ever learned in my life, and I have learned a lot of disturbing things. Scientists have found what they call graveyards. Clusters of infected ants, dozens, sometimes hundreds, all bitten onto leaves in the same small area of forest, all in the same position, all with stalks growing from their heads. The ants didn't go there by accident. Something, the fungus, the chemicals, some mechanism we don't fully understand, concentrated them, brought them to the same spot. Researchers believe the fungus may be communicating across hosts. That infected ants may be drawn to areas of existing infection, creating these clusters to maximize spore density in a single location. Let me say that again more clearly. The fungus may be coordinating across individual hosts. Not a hive mind in the science fiction sense, but a chemical ecosystem, a network of dying ants and growing stalks working together without knowing they're working together to create the most effective spore dispersal system possible. It doesn't need a brain. It built a strategy without one. The Last of Us ends, depending on which season you've watched, with some form of hope, a cure, a resistance, human ingenuity finding a way through. Real nature doesn't write those endings. Ophiocordyceps has been doing this for at least 48 million years. We know this because scientists found a fossilized leaf, 48 million years old, with the distinctive bite marks of an infected ant preserved in the surface. 48 million years ago, a fungus made an ant climb a leaf, lock its jaw, and die in exactly the same way it happens today. The dinosaurs were gone, humans didn't exist, and this fungus was already running the same program it runs right now in forests around the world, every single day. The show asked what would happen if this came for us. I'd like to suggest a different question. What makes you think we're special enough to be worth targeting? The fungus has a type. It commits. We're not its type. But the carpenter ant thought it was fine too.